Hello friends, for the example means exercise 9.22, the question is okay, for what angle of incident for the prism so the emergent ray remains parallel to the surface AC, means it's just fill the total internal reflection. The question is for what angle of incident for the prism. So the emergent ray is just total internally reflected. Just total internally reflected means it remains parallel to the surface AC. And whenever it remains parallel to the surface AC, then the angle of emergent remains 90 degree, which is already shown in figure. Just remember the diagram for the prism. Okay, I is angle of incident, R1 and R2 are the internal angles for the prism, and the angle of emergent is 90 degree, and the refractive index is given for the prism is 1.524 and prism angle is 60 degree. Then start from the surface AC. Just apply the Snell's law for the surface AC. There, angle of emergent is 90 degree, and for air, just consider eta 1 as a 1. Therefore, when we apply the Snell's law, we can say eta 2 sine R2 is equal to eta 1 sine 90. The right hand side is 1. And eta 2 is the refractive index of the prism, just consider as a eta. Then we can say sine R2 is equal to 1 upon eta. Therefore 1 upon 1.524. This value is near about 0.6562. Then when we see the sine angle, therefore R2 is near about 41 degree. Then see the diagram. Here R2 is 41 degree and we know that A is equal to R1 plus R2. That's why R1 is A minus R2 and it is 60 degree minus 41, that is 19 degree. Then once again see the diagram. The R1 is 90 degree and just apply the Snell's law for the surface AB. Then eta 1 sine I is equal to eta 2 sine R1. Therefore eta 1 for the air is 1 and sine I eta 2 as a refractive index of prism, that is 1.524, and R1 is 19 degree. Just see the value of sine 19 degree, it is near about 0.3255. Then do the multiplication and just see the angle for the sine, it is near about 29.75 degree. Then we can say for the prism, if angle of incident is near about 29.75 degree, the emergent ray is just internally reflected, means it remains parallel to the surface AC. Now for the example of exercise 11, for that one, focal length of objective given 2 centimeter, focal length of eyepiece given as a 6.25 centimeter, and the distance between two lens given 15 centimeter. Means this question regarding with our microscope. Here two lenses are there, one we can say objective, another eyepiece, and distance between them is 15 centimeter. Matlab distance between objective lens and eyepiece given as a 15 centimeter, and in question asks that for what object distance. So the final image is formed at near point. The first part of the question is for what value of the object distance. So the final image is formed at near point. We know that near point is 25 centimeter and this is from the eyepiece. That's why we have to start the calculation from eyepiece lens, because final image from eyepiece. That's why the D is 25 centimeter. Now we can say for the eyepiece. तो eyepiece से वही डिस्टेंस V2 is 25 सेंटीमीटर ही होगा. Then consider the object distance for the eyepiece is U2. Just use the lens formula. 1 upon F2 is equal to 1 upon V2 minus 1 upon U2. Say the 2 for the eyepiece lens. 1 we can say for the objective. That's why 1 upon F2 is equal to 1 upon V2 minus 1 upon U2. Make subject 1 upon U2 and just place the value. Here V2 means 25 centimeter, but according to the sign convention it is minus 25 centimeter. That's why it is minus 1 upon 25. Focal length of the eyepiece is 6.25. That's why 1 upon 6.25 उसकी नेसेसरी कैलकुलेशन करो. U2 मिलेगा तुम्हें minus 5 centimeter. So here the distance between two lens given as a 15 centimeter. That's why this distance, object distance for eyepiece lens, it means in between the objective lens and eyepiece lens, the distance between objective and eyepiece is 15 centimeter. Therefore the image distance from objective lens is 10 centimeter. Now we got the image distance for the objective is 10 centimeter. Then using lens formula once again we can calculate the object distance for the objective lens. That's why 1 upon U1 is equal to 1 upon V1 minus 1 upon F1. सभी वैल्यूज रख दो. V as a 10 centimeter, focal length as a 2 centimeter, and do the necessary calculation, and we can get U1 is 2.5 centimeter minus 2.5 centimeter. Therefore we can say object should be placed at 2.5 centimeter. So then final image is formed at near point means 25 centimeter. In second question given that, okay, here we have to calculate the magnification in that case also. So for the near point, the magnification for the eyepiece is 1 plus D upon F2, and magnification for the microscope is MO into ME. For the objective we can say V by U, but V1 upon U1. Here we will use the magnitude for the U1, and for the eyepiece 1 plus D upon F2. Therefore just place the values of all. Then 10 by 2.5, 1 plus 25 upon 6.25. Do the necessary calculation. We can get magnification at that cat is 20 centimeter. Now in second part it is asked that, okay, what should be the object distance from the objective. So final image format infinity means for the eyepiece image is at infinity, we can say V2 is equal to infinity. Then using lens formula we can get U2 as a 6.25 centimeter. The distance between two lenses is 15 centimeter. Therefore image distance from objective lens is 8.75 centimeter. Then once again use the lens formula for the objective lens. Therefore 1 upon U1 is equal to 1 upon V1 minus 1 upon F1. Do the necessary calculation, substitute the all values, and we can get U1 as a minus 2.59 centimeter. So here we can say the object should be placed at 2.59 centimeter from the objective lens. So the final image format infinity. In case of infinity, the magnification formula for the microscope same MO into ME, but for the ME is D upon F2. Therefore magnification MO as a V by U1 and D upon F2. Therefore magnification is 13.51.